Hello again, and welcome to the first video in Enemies and AI series. I am a fan of exponential utility graphs, so as with character controller series, this series will start pretty slow. We will establish some core architecture agreements, we will clear some misconceptions and assume some assumptions. Then I want to implement several enemy ideas from easier to more complex. We will start from a default 2005 MMO mob logic. Then I want to create a boss fight with something big and bestial. Then I want to create a player-size melee opponent, a mirror, but I want to implement it in a way it will be hard to combat. And finally, I want to create some other than combat behaviors. Probably something like a guardsman in a stealth game, or an NPC functioneer on a farm. I also have some meta comments about the series. I let the audience decide what's next, and you have picked the theme I know the least about. Life is funny sometimes, however, this series will give me an ability to experiment on the format a bit. I want this series to be more chill. I will allow myself to take more pauses to show the code, and as I was forced to do a lengthy research before the series, I want to narrate it as well because I believe an ability to code and any deep engine knowledge is far less important than a skill to learn in the right way. I want to start our AI journey from a little bit of mind opening. While a game developer can be competent in combat design, network design or marketing strategies, no matter how long you have worked in the industry, you are fundamentally incompetent for the task to create an enemy for your players. To take any assumptions about your results as an enemy designer, you'd better have some objective metrics to apply to it. But here's a catch. Network engineer or an SMM specialist can have objective metrics about the system they build or practices they use, but you will never get objective data about the enemy you produced. Thanks to the fact you know how it operates internally, you can't take your feedback about it, as it does differ from the experience the player gets facing your enemy. Objective information about the player's experience with your enemy can be obtained only by the test case player who faced it, but here the dark truth about our world pushes us. That objective information about your enemy forms inside the test case player's head, and no one on this planet, ever, will get an access to it, including you, sadly, and in most cases even the test player in question. The reason of this is the dark nature of signaling. Most of the information we have actually is assumed. You can guarantee you quotes know something only if this event occurred quotes in your hands. The moment the event is remote, you are making informed assumptions. For example, if you have a perfect watches on your hand, you can say you know what the time is it for you, but you can never be sure what time is it on the watches of your friend who stands a meter from you. The best thing you can try is to ask him what time he has on his watches and listen to his response. Then doing some rituals to narrow the information about his watches to a plausible error magnitude. This can generally bear usable results, but for these rituals to work, you still need to make a bunch of assumptions. What I want to tell is we can't know shit even about the most formal data transfers between perfect peers. But getting a proper feedback in the form of human language words? Strictly speaking, you have zero guarantees that the meaning you put into the words you spoke is the same as the meaning the receiver of your words unpacked in his head while listening. Think of your communications with elderly or about the times of arguments with your significant other. Human language is a ripe signal system, but it pays great price in losses for its expressive powers. This is the reason you need as much test audience you can get and as excessive feedback logs you can force them to produce. No matter how you try, you can never get a hold of an objective feedback about an enemy you created. The best you can hope for is to narrow the field of error for this unchaseable variable. Pretty huge error magnitude, I must say, because humans are individuals. Even if you have divided them into 20 different groups with tags attached, there are no two alike, and all your feedback papers, all the data, pray for it to add more to your knowledge than to your ignorance. Why am I wasting time on it? What positive lesson can we get as game designers? Well, the acknowledgement is the half of the solution. If you manage to truly accept despair, we can finally stop trying and put our eyes onto the right tools and philosophies. Game designer, is an architect of player's experience, and enemy design in particular is much more close to an art than to something strictly defined as, for example, networking. Embracing our artist nature, we can finally define the right metrics that can be applied to an enemy we created. An enemy is an expression tool. Does the player on average experience the target image we want to put into an enemy? Your enemy has a location of habitat. Does it fit into its environment? Does it have the right visual and sound attributes? Your enemy has two purposes. First is its design purpose from you as a game designer, a task to fulfill in your game sequence image or a problem for the player to overcome. Second is the purpose attributed to the enemy by game's narrative. Does your enemy has these two purposes figured out and written down, and do they naturally coexist? Does your enemy tell a story about overcoming it? How many of them does it tell? And the most important, in my opinion, what is your enemy's designed weakness? As you are an architect of player's experience, you need to be consciously aware of the fact that while creating an enemy, you are putting your soul and passion into something that intentionally won't succeed. Your success is your players being happy about themselves at some point playing your game. Every single enemy in your game needs to be created and placed with the idea of being defeated in mind. There are different strategies to achieve this. You can straight up design failure into an enemy, for example a giant ram boss that charges over the arena to get stuck in the wall for several seconds, leaving a window of vulnerability. You can as well design failure lower during an implementation phase. For example, your boss genuinely tries to outskill the player in melee combat, but his animations and combos have shortcomings intentionally put there for the player to use. Or in an extreme case, you can just, quotes, make an enemy good at its job by not designing failure at all and hoping that players will outplay your enemy anyway. However, if you want to do this, I want you to be consciously aware about this choice. Look into the eyes of your mirror image and say it out loud. I do not design a failure into my enemies, and I hope my players will design it for me. Then mark this thought in documentation and test cases to return. If you understood you made your enemy a competent opponent and the outplays from test players aren't emerging, you failed. If you have created an enemy that has no weakness and no preferred tactics against, you have created an encounter that guarantees some static resource cost to your players to participate in that they can diminish by their own skill. And if that's the case, why the fuck do you even force players to spend the time? Just reduce the resources by that value forcibly in a cutscene, or by some other design like the floor is burning hot and you took damage by existing. Concluding the section. No objective metrics can be created to estimate the quality of an enemy. Screw objective metrics. Use purposely vague metrics of an artistic nature, presumably in the form of questions. These questions are to be answered by both you and your test audience, and the parameter we want to maximize is the likeness of these two feedback answer pools. Further research materials. For depressed and thoughtful McConaughey vibes, you can Google the theory of falsibility and verifiability principles, their pros and cons. Then try to research building of a software representation of knowledge. Then polish this by a little bit of relativity theory and some classical problems like clock synchronizing. For more down-to-earth information and inspiration, read in short any design and narration guides you can get your hands on. How to write dialogues for cinema, how to create visual design for a character to match with its mentality, how to create locations, how to design monsters, how to narrate through mediated signals. Also, by chance, if you have any relation to TTRPGs as a player or as a game master, I encourage you to grab and reread the Dungeon Master Manual for your game or just a D&D one. I kid you not, this book does help in game development as well, because look at the definition again, an architect of player's experience. And the last bit of materials I want to link is this talk on enemies AI and its brilliant message. The link is in the description. Now, when we agreed on a common ground of us being designers, we need some theoretical preparations in the field we want to excel. The problem of an intelligent agent predates any computer games. Humanity invented a lot of wheels on this way and wrote a shit ton of theory. A quick research leaves us with several overarching terms and abbreviations. These terms contain a lot of places to assume and to outright get wrong, so at minimum we need to agree on terminology. I have this slide stolen from a presentation either. Use these questions as tables rows and your terms as columns. Complete the table in your spare time. To save video's integrity, I will answer only the first question for the most used buzzwords. State machine is an abstract system that can be in one state at a time and changes its state if some inputs is received. In relation to games, in the most cases we describe systems with a finite amount of state, so we can call it a finite state machine, or FSM. Behavior tree is a smart-ass logical tree that operates nodes of three types to construct a plan realizing a complex but static way to solve a problem. These nodes are a solution part that contains actions to perform, a selector node that has a bunch of other nodes as children and is satisfied when one of them is executed successfully, and sequence node that contains a bunch of nodes as children and executes all of them before it considers itself satisfied. GOAP, for goal-oriented action planning, is a way to organize agents' plan execution in the form of providing the action breaks to an agent, but leaving the plan forming to the agent itself in a dynamical environment. BDI, for belief, desire, intention, is a high abstraction level model of an agent that does its decision on a basis of predefined mental characteristics. BDI is mostly about the process of decision making and not about the actions planning for the future. This is extremely short and informal way to put things. If you feel you need additional information, you can read some internet articles or watch some videos. Here's what I will suggest. They are short and good in explanation. Feel free to stop and return later, or to rewatch the video, but from here I conclude that the viewer is familiar with these theoretical concepts and I am slowly moving to discussing specifics of their implementation in Godot. But the most important thing I want to take from this long intro is the statement about the tool choice. There are so many ways to create an AI for your enemy because they are best for different things. You can implement any solution with any architecture. The first thing you must concern is what architecture do you want to use for your enemy. Surely this series will end up with some genius AI with GOAP for planning and utility theory for top layer decisions, but should you end up with it? Look at this bet. Do you really need more than if so player then go explode for it to work? Always start from choosing a stick of appropriate size for the task. But before finally moving to implementing things in Godot, I want another round of unassuming assumptions. I generally preach self-awareness, but today we will discuss a very dangerous logical pitfall. Theoretic model of a solution is a very different thing from practical implementation of it, and great delusions may appear if you fail to distinguish them. CCP and USSR are not communist countries, and USA is an implementation of democracy, but not the brightest example of it. Before I lose more subscribers, let's move to our main field, game development. Here is an example of pseudo-enemy I created to test parries for a controller demo. My character controller is an implementation of a state machine which reacts to inputs issued by a player. Then an enemy is just a cloned character state machine with different skin and a script that hijacks the input gathering. Now, the question for audience. Does this enemy fall into a state machine enemy category because it is updated as one? Or does it fall into unstructured script category because the decisions are made by single awful piece of a function? Well, both. Or I would say, no category at all. Next illustration. Imagine 4 GOAP AI implementation. First uses a neural network to form a top-level goal once in a while, then plans and updates with GOAP. Second is using an utility theory-packed priority decision maker for top goals. Third uses a simple script that just cycles top-level goals at fixed rate as a clicker bot. And the fourth doesn't use additional decisions layers at all, just a pure GOAP with a single giant top-level goal of something like win the game. Which of them is more GOAP than others? Well, the thing is, all of them are the same, as long as implementation is goal-oriented and plans actions in a certain way, it is an implementation of GOAP AI, period. Every single implementation is unique and can be universally described as a wall. Instead, it is described as an implementation of some theoretical model to analyze it from this model point of view, but it is a very rare for a solution to be described from a single theoretical standpoint. Let's use a good real-world example. Imagine two cans of pressured gases which explosively react when mixed. What happens there truly only God knows, but we have at least three ways to talk about the process. We can call it kinetic theory of gases to analyze it as a bunch of colliding balls. We can call it thermodynamics and analyze it as a single entity which undergoes a process of transforming one type of energy into another. Or we can call it chemistry and write the reaction equality with water generation and fast energy freeing in the form of explosion. But what description is right is decided only by an analytic goal we pursue. Figuring out these seemingly unimportant problems is not an empty token. These mind experiments are helping you to build your general world picture. They help you to consciously understand the meaning of the terms you use in internal dialogues and to find white spaces of incomplete understanding if you encounter a paradox. Being able to analyze your implementation from a perspective of a single theoretical model bears wonderful fruits. I often say that every character is a state machine even if its code has nothing to do with an implementation of one. What I mean, even if an entity is not implemented as a state machine, theoretically it is one, as long as it can be exactly in one of a finite number of states at any given time and can change from one state to another in response to some inputs. Even if I skip literal state machine creation, this knowledge can help me to pull my head out of my ass and at least decouple my transition logic from my update logic if my clean code sense fails to do that.
I see boxes and lines.
In your dreams?
Those who are used to live in a looming shadow of state machine start to see the different parts of it even in seemingly unrelated practical implementations. In fact, the fundamental division between transition logic and being in a state logic is so strong, one can start to explore ways to architecturally divide them. Look again into my GOAPness illustration. First three solutions have a clear line between the deciding part, or I would say the brain of an agent, and an execution part, the arms. This, ladies and gentlemen, is a natural border for strong decoupling. If done right, I can slot in and out different algorithms into these parts without huge differences for the other side. And this is the classification of AI algorithms I prefer: decision makers and practical means of achieving. If you don't like or don't need to have one of the parts, you can. Some enemies don't need to have achievement parts at all, for example an AI opponent in chess. Some enemies don't need to have a decision mechanism, for example a mob from Path of Exile that just activates from idle state into an aggrate state when it sees the player only to die a second later. But what actually happens in these cases? Chess opponent does, quotes, achieve the combat, just with rudimentary complexity of moving a figure in its operative memory from one place to another into the array. Path of Exile mob does in fact, quote decide to aggro, it at least has a single boolean flag for the state flipping. These examples in fact do have both counterparts of an enemy implementation, but one of them is so small we barely see it and is of type of an unstructured script. Whew. Now we are finally equipped to think about practical implementations, but we have a lot of work before us still. Prior to any implementation brainstorming, you'd better do another research, a research on already existing implementations for your field, so let's discuss that. I want to lift 4 topics. These 2 bits from This Is Vinny, which I think have undeservedly low amount of use, then the Behave add-on by BitBrain, then another TED Talk with conclusions. Why these 3? Because they are the best I found by the topics of behavior tree, GOAP and utility system implementations. You don't have to watch them to understand me, but you may want. First, the Behave add-on, the ideal thing for me. I as a human am biased and I don't like behavior trees. And Behave is perfect, because it is very solid work, it is polished, it has a site with documentation and video lessons, so on one hand I don't want to even make a video on behavior trees, and on the other hand, doing a video on behavior trees while this thing exists is kinda silly. So if you think behavior tree is the way to go, learn some theory on them outside from Godot, then visit the Behave, either use it or steal their code in parts. Done. Next, Vinny's GOAP and utility theory. Both are solid in my opinion, but I want to build them a bit different. Different abstraction here and there, different control flow, different data flow, etc. So I, as a human, adore utility theory and GOAP architecture, and these solutions are solid but imperfect in my opinion. Naturally, I will do an extensive video on utility system design and on GOAP myself, but I also want to lift another curtain. Learning how to create utility system by Vinny's example is cool, but the better knowledge is how to become Vinny in this timeline. Here's how. I didn't manage to find this talk on YouTube, but it is here on GDC Vault. First, the talk itself is very good. If you plan on using utility theory as a whole, give it a view. But secondly, the first speaker is an author of a book on the matter, and the talk itself is kinda a net trailer for it, so if you really want to dive in, read the book. And the funny story about the book, God's favorite written, I guess. I tried to Google the PDF and found it on the first link. The book is full and I noticed an unusual address line, so if you delete this, you will get to a list of books on AI for game dev. Which is cool, but if you delete another section, you will find a fucking treasury. Each hyperlink here leads not to a book or an article, but to a list of books and articles, sorted and put by theme. Whoever is this individual, I have no words to describe my respect. Now let's do something already. Here we have a level and a player character. Let's also create an angry mob for us to kill. Screw visuals, let's slay an evil red capsule at first. My first enemy incarnation will be a scene of a single component. A character body 3D with a collider, a mesh and a single script for unstructured AI behavior. Now what do? We are guarding our spawn place. Let's remember it already. Now, if our player comes closer than some distance, we start to aggressively pursue them until the player runs away far enough for us to deaggro. Let's also add a behavior for quote attacking the player if we are close enough to them, and a behavior for diagreeing, in which we become unbothered by distractors and return to the spawn place we guard. Now, to deepen our fall, let's make him animated. Drag and drop here a humanoid scene with 3 animations and wire some spaghettis. Yes, we can further extend our behaviors. We can add here a simple patrolling or even a smarter patrolling with usage of navigation agents, but this whole design probably stands against every single principle I try to follow on this channel, so I will discard this nonsense. Never do this to yourself or to your projects. And if you want to know what to do instead, see you in the next episode.